Okay, so we're going to start with just a quick introduction. I'll start. Hello, my name is Mayan Berger, and I lead our data intelligence delivery team here at Curis. And Cameron, Carlos, can you please introduce yourselves as well?
Cameron, you may be on mute, but I'm Carlos Bloy. I'm a partner solution architect supporting our strategic tech partners here at Snowflake.
Yes, thank you, Carlos. I double muted myself. Hi, everybody. I'm Cameron Davey. I'm the partner solution architect here at Talend. I'm responsible for our technology relationship between Talend and Snowflake.
Great, thank you. So first, we'll start with a quick intro of Curis. Curis is a data consulting company specializing in big data warehousing solutions. Over the past 20 plus years, we've implemented hundreds of successful data warehouse solutions. In that time, we have used many different technologies and methodologies to implement these data warehouse solutions. This includes traditional on-prem solutions, so-called big data solutions like Hadoop, native cloud solutions from big vendors, and virtually every ETL tool or ELT tool you've ever heard of. Having seen all of these options, our team prefers Talend and Snowflake for client projects. We've done dozens of implementations with these two technologies over the last 2 years. We wanted to mention two of our most recent implementations here in the US that we've done with that technology stack. Those are two very interesting use cases which would require their own webinar to cover everything there is to say about them. So we'll just touch on these very briefly. First, we had a big data use case with OUC integrating their electric and meter data. The solution we implemented there integrates thousands of files a day, allowing them to leverage data that they didn't have access to before. The second use case, which is still in progress, is for Shake Shack. We're working with them on creating a data warehouse that will combine their POS data with their app activity data to be able to get to know their customer behavior much better and allow them to make personalized recommendations. I will now hand it over to Carlos to give us an overview of the Talend platform, of the Snowflake platform. Sorry.
Concepts about Snowflake, but then Mayan later will dig on to some of the technical features. Next slide, please. So the rise of the cloud. The cloud, after the cloud started, Snowflake really came about after the inception of the cloud. We started in 2012, and our founders looked at the benefits as to what the cloud provides. And what they recognized that the cloud would provide unlimited storage and unlimited compute. Now, in 2012, with the birth of Snowflake, we were never an on-premise environment. We were architected for the cloud uh, in a way such that you're able to take advantage of the cloud capabilities of the unlimited storage and the unlimited compute. And in that, a key feature of our architecture is that we separated compute from storage. And because of that basic architecture implementation of separating those two components, we are able to take advantage and scale better than any other solution in the cloud. And mine will get into some of these details in the implementation of our virtual warehouses that run on our platform. And so with the rise of the cloud, we just have many customers being mandated to go to the cloud. The days of COVID, where everybody's isolated, being able to work with cloud-based solutions are becoming more and more important. Then over recently, you have more of an explosion of data. You would traditionally get your ERP application data into Snowflake, your transactional log data into a data warehouse solution. More recently, you have IoT and mobile data that more traditionally, historically sat on Hadoop environments. Well, with the advent of Hadoop not really delivering on its promise to be able to manage the data and also be a data warehouse at the same time, Snowflake, with our capabilities, you're able to load your Hadoop data and your structured traditional data warehouse data in a single platform and query it from a single query to do analytics. And then also there's been a diversification of analytics. You got your traditional BI reporting, and now today you have more data science going on, AI, ML going against that data that you have in your cloud data platform. Next slide, please. So when Snowflake came about in 2012, we came about as a data warehouse built for the cloud solution. I mentioned a couple of our capabilities as far as being able to support semi-structured data natively in a data warehouse. So that's definitely a core capability of ours. Now, in some scenarios, customers are using cloud storage to implement data lakes. We have features such as external functions where you get access to that data in your cloud storage without having to actually bring the data into Snowflake, but it gives you a 360-degree view of all your data, whereby data that's in your data warehouse can be queried along with data that's in your data lake. And we absolutely support the data lake implementation of Snowflake. So it's a core cloud data capability, cloud platform capability that we have. We also have a concept of data engineering where you can land your data into Snowflake and then take processes to further apply business rules to get data transformed and landed into tables for reporting users to access in Snowflake. Enhancing features for data science, where we're pushing down functions whereby you can call on models from your AI ML applications from internally from Snowflake as part of our SQL, specifically an external function call. Enhancing data applications, doing more embedding of processes into Snowflake. And then also a concept called data exchange, which started with a concept of data sharing. But essentially, you could have multiple Snowflake accounts share data with each other, much like a view in a database, but without actually having to take another account's data, receive that data, and load it up into my account before I can work with it. It's just another Snowflake account will publish a share to me where I can just query the data with the data that they shared. And there are unique benefits from that solution as well. But we've extended the concept of data sharing to data exchange, whereby we have Snowflake customers that are sharing data and publishing data and using it as a commodity to share with other Snowflake customers. A more popular recent data exchange data share that was published was like the COVID data. So I recommend you go out there and look at it and play around with data exchange, but it's a very powerful solution today. And then Snowflake, we run on all three clouds. And as a single customer now, with the concept of new features such as organizations, you can essentially run your company all three clouds simultaneously at the same time. And Snowflake is Snowflake regardless of what cloud you're running on. Next slide, please. So I like to refer to architecture as an elegant architecture. And so there's really only three layers to it. At its core is storage. And I already mentioned that the compute is separated from storage. One key feature about our storage is it's infinitely available to us. We have as much cloud storage as we need. So you get as much storage as you need. One key feature about our storage is that it's immutable. So therefore, when you apply an insert, update, delete, we do not actually remove that data. We just append new data into what we call micropartitions, and micropartitions is the way we store the data. But that will allow certain benefits such as time travel, and you'll learn about time travel on future slides. And the light blue area is our virtual compute layer. It's our multi-cluster compute. Now, there are certain capabilities there. You could define a virtual warehouse. We define our virtual warehouse in terms of t-shirt sizes. Extra small, small, medium, large, and they all translate to different cluster sizes. Key feature about virtual warehouses, I can increase the size of a virtual warehouse instantly. And since the compute is separated from the storage, I don't have to do things like repartition my data. I just define a larger virtual warehouse and I get faster query performance. Another key feature about virtual warehouses, if you have a virtual warehouse set up at a certain size and you have many users querying that virtual warehouse at the same time, say Monday morning reporting problem, you have a peak period. Snowflake, we recognize that there's a queue building up of users wanting to run reports. With virtual warehouses, we can instantly start another virtual warehouse of the same definition, And now I automatically have a second virtual warehouse, a second cluster available to me to run these queries. So we monitor the queue for the initial virtual warehouses, and what we'll start doing is migrating users to the second virtual warehouse that we just started up and do load balancing across those two virtual warehouses. So we're able to address concurrency issues where resource contention becomes a problem. We don't have that issue with Snowflake. We can meet your SLAs, and we can scale out virtual warehouses all the way up to 10 virtual warehouses all running at the same time, and we manage all that for you from our cloud services layer. Our cloud services layer is the highest level within our Snowflake architecture, and that's where we manage your virtual warehouses, we manage your users, we come up with an optimizer plan, and that's just Snowflake in the cloud running 24/7. Next slide, please. So Snowflake, I will be hanging around until the end of this call to answer any questions you may have, and you're going to be learning more of our features with what Maya is going to be delivering to you in her slides, but I will stick around for any questions at the end. So thank you for your time.
Thank you so much, Carlos. Cameron, can you take it away with an overview of Talend?
You got it. Thank you, Maya. So let's obviously great stuff from Carlos in giving you an overview of what Snowflake is all about. And with Talend, we're working very directly with Snowflake from a data management, data integration standpoint. Next slide, please. So just a quick overview of Talend. We are a global leader in data integration, data management, and data integrity. We were founded in 2005 based on open source technology, and that's very important as we are developing, we have developed Talend into a true open company with open standards based on compelling and emerging industry trends. We are a public company. You can find us on NASDAQ. We have over 1,300 employees, over 4,200 customers, and we have been recognized as a leader by the leading industry analysts, including most recently on the Q2 2020 Forrester Wave for data integration. Next slide, please. And if you can build out this slide, please. The real challenge that a lot of businesses are facing is in addressing the true problems that they have with respect to their data. They need to be able to turn raw data into revenue, to be able to innovate faster. Obviously, as we've seen over the last few months, everybody is moving as quickly as they can to a digital or cloud-based environment. And that does pose a lot of challenges from a data management standpoint. Tackling these goals requires turning that raw data, this chaotic data that you see on the left-hand side from a multitude of different sources, and turning that into smarter, trusted data with intelligence. Now, the first step of this, and this is where the Talend Data Fabric helps solve these problems, is the first to collect that data. And by collecting that data, you have access to hundreds, if not thousands, of different data sources out there, whether they're cloud applications, SaaS applications, on-premise, whatever those may be. Talend has over 1,000 different built-in connectors and components to help you start to wrangle that data in directly. The next step is to govern that data. So it's one thing to collect that data and to land it somewhere, but we also need to make sure that we are governing that data. One thing that is very important within Talend is the ability to democratize the access to the data, and that's all well and good, but you also need to make sure that you are governing who has access to that data and what they are doing to that data. Now, very typically within Talend, within data management and data integration applications, you will have data architects and data engineers who are the primary users of those. They are responsible for connecting to data sources by transforming the data and then landing that data into a data target or a data warehouse, like Snowflake. But we have more and more roles or more users within a business, within an environment that have access and that need access to that data. Integration specialists, people who are very responsible for particular applications. Data scientists who are turning this raw data and using it for machine learning and AI types of purposes. Data stewards who are responsible for challenging the outcome of that data by making sure that the data that has been output is the correct data. And then you have the citizen integrators and analysts, the people who are at the front lines of using that data and that have a key insight into what that data needs to look like. So with all of these different types of users, having a strict oversight on governance is critical in any organization. So we've collected that data, we're governing that data, but most importantly, in this type of environment, we need to also make sure that we are transforming that data effectively. By being able to do this faster in both batch and in real time with as many capabilities as possible, and that is what the Talend Data Fabric provides. And then finally is the ability to share that data. So it's sure you want to be able to collect and transform that data, but I also need to be able to get that data out into the business in the manner that they need. And that can be through APIs, and that can be simply through the ability to share that data. Now, where Talend excels is the fact that Talend it can support multi-cloud environments, hybrid environments, and on-premise as well. So as you are on your way, on your journey to cloud-based data management, Talend can help you because we can support those environments that are either on multiple clouds as you're making your decisions, or as you're moving from on-premise to cloud. Those types of hybrid solutions Talend supports extremely well. Next slide, please. So this is to give you an idea of all of the different capabilities, components, apps, if you will, within the Talend Data Fabric. The Talend Data Fabric is a single unified application platform to provide all of these different functionalities and capabilities. Certainly the main one would be data integration, the ability for the modern data engineer to collect, transform, and share that data. Along the way, data quality and data governance are key. We have also newly introduced data inventory, which allows you to capture data intelligence at first sight, being able to provide your users a trust score of that data so that you can know right away, should I trust this data that's coming in? In other words, is it valid data? Is it usable data? And you can use the rest of the tools within the platform, such as data preparation and the data integration tools combined to improve that trust score of that data. And today we're going to be seeing a lot of focus specifically around data integration and the quality of that data and how it relates to Snowflake. So with that, I will turn it back over to mine and the Kira's team. Thank you. And like Carlos, I will be around for the rest of today's conversation to answer any questions that you've got. Thank you. Back to you.
Thank you, Cameron. So we'll move on to discussing common data warehousing challenges and how we solve them. Building a data warehouse takes an investment of time and money, which is significant because Gartner says that incredibly, over 50% of data warehousing projects fail to make it through user acceptance. At Keras, we developed a methodology and technical framework for data warehousing, prioritizing 3 basic objectives to ensure that these projects succeed. We recommend that you consider them as well. The solution needs to be scalable to support future growth. It needs to be reliable to ensure consumers trust the data in the solution, and it needs to be accessible by different audiences in the organization. We will start with scalable. So why is scalable important? It sounds like it would be, but what exactly does it mean in this context? Here are a few examples of challenges and common mistakes we see with our clients regarding their data platform that speaks to why having a scalable solution is indeed important. In short, it's important to understand that as a company evolves, so do its data and analytical needs. So the platform that you design and build now should be fit or be flexible enough to address tomorrow's needs as well. That goes both in terms of additional use cases and requirements that come up, new applications that need to be integrated to an existing data warehouse, and fast. As the organization gets used to using their data, their appetite grows, and we need to be ready for that. That also applies in terms of technical capabilities and performance. You want to be using technologies that will grow with you as your data grows, that can be adjusted to handle large volumes of data without having to revamp the entire platform every year or so. We will cover two examples from our framework today. First is our concept of creating jobs that are configuration driven and reusable, meaning one job is reused to execute the load or transformation of several different entities or tables. A job in Talend is the term for a pipeline. Essentially, it's a sequence of steps with dependency between them that execute operations on a set of data. We feed variables into the job during runtime, which determine the exact data set or table that Talend will be processing. The benefit there is that our solution ends up with significantly fewer pipelines in total compared to a more traditional approach of ETL, which is much more manageable and easier to maintain long term, as well as easy to onboard new data sources or new business entities into the existing platform. The second thing that we wanted to mention today was different ways we leverage the power of the cloud in both Talend and Snowflake. So a couple of examples. First, we ingest huge data sets to Snowflake quickly using a special copy command which processes chunks of data rather than inserting the data row by row. And second, we use Talend's ELT components to apply in-database transformations on large data sets, like doing joins or filters using Snowflake's compute power, rather than having the data flow through Talend, which wouldn't be efficient for large volumes of data. We will go into both of these examples in more detail. Before we dive into the demo, let's visualize its architecture here and the configuration-driven jobs in the next slide. The steps to warehousing massive data sets at our clients tend to look something like this data flow. The source data that we're going to be working with today is JSON files that came from a POS system. It has sales transactions and separately customer information. We'll assume that there was a prior step to pull the data from the source system using an API most likely and land the data in S3. The first step of the flow is to parse the JSON so that we can more easily analyze it later on. We do that with Talend very easily, and we will show this. We then land the data in another folder in S3 as a temporary landing area before loading it into Snowflake. We then copy the data into Snowflake into our ODS layer, which is Operational Data Store, which stores the data parsed as is, just in tables. Our last step is the T part of the ELT, and those are going to be the transformations applied to the raw data so that it's ready for reporting, for data exploration, and so on. Finally, configuration-driven jobs have this structure of a master job and a child job. Most of the operations that can be generic are done in a master job. The child jobs are much simpler and only include entity-specific operations. The parameters are fed from a control table in Snowflake, and they determine the exact data set or table to be processed during the execution, oftentimes iterating through several entities. From the master job, we execute the relevant child jobs. So we will now dive into the first part of the demo. We will show how our generic jobs are used to ingest data from S3 into Snowflake, including a copy command. And then we will show an example of an ELT job in Talend. So I am going to share Talend here. So for those of you who are seeing Talend for the first time, I'll just give a quick tour of what we have here on the screen. So on the left side here, this is our repository. This is where we can navigate between the different jobs that we have created. You can see they're kind of organized in different folders just to make it easier to navigate. In the center of the screen here, this is our canvas. This is where we structure the jobs and create the flow of the different components with dependencies and so on. On the right side here, we have our palette, which is where we choose different components to drag into our job or into our canvas. And you can see that the different components here are kind of bucketed according to relevant types of components to make it easier to find the component that you're looking for. And then lastly, here on the bottom, this is our configuration screen. So whenever we're working on a specific component in the job, on the bottom here, this is where we're going to define the different settings that would go into that component. And you can see as I move from one component to another component, the settings or configurations that are slightly changed according to the specific component that we're working with. So we will now start with the first job, and you can see it's a master job. It's called Landing Zone to Enrich Master, and this goes back to the master-child relationship concept that I showed him in the last slide. So this first master job is responsible to taking the JSON files that we're going to be working with and parsing them. So the files that we're working with today, this is an example of what one of the files looks like. You can see we have sales transaction here, multiple transactions within the same file, and this is a JSON file, so we're going to need to parse it. The purple components that you see here are related to logging. We're going to skip these for now, and we're going to get to logging a little bit later in the demo. So the first thing that happens here is that we read from this admin control table that I mentioned earlier. This is the table that we have stored in Snowflake, which is used to feed the relevant parameters into the job to determine exactly what file or what table we're processing in each execution. Once we have the relevant variables, we iterate through them and we move on to the next step here, which is this yellow container here on the top. So this part is to take the relevant files from our landing zone in S3. And what you can see here is that we're actually iterating through 20 files in parallel. So this is going to make the execution much more efficient. And you can see, of course, that we can change the number of files that we want to process in parallel according to the performance that we want to achieve and the total number of files that we know that we have to deal with. Once we've grabbed all of the files that we need, our next kind of big step here is to parse them. So we're doing that by executing a child job. So you can see this component right here is actually responsible for triggering another job. You can see that the component name here is run job. And what's unique about this specific step is that we're not executing a specific child job, but rather we're using this setting, use dynamic job, which you can see right here, which allows us to actually execute multiple child jobs, and the specific job that will be executed will be determined by one of the variables that we're going to feed through kind of the first steps of this job. So in this example, we have two child jobs, one for customer, one for sales data, because the files themselves are, of course, very differently between these two data sets. But in a real implementation, of course, this could be many more child jobs as well. Each of the child jobs look very similarly. We're just going to look at one of them. So this is the child job that is responsible for parsing the sales data. And you can see there's only a few steps here. Just as a reminder, the reason that this is done in a child job is because each job has to be specific to the settings of the file that we're parsing. So we're doing this very easily using this component in Talend, which allows to very easily define the structure of the JSON file and exactly what fields we're expecting to receive in that file. We then have this enrich step where we just add a few additional fields or columns into our data set. For example, we're adding the file name so that we can trace for every single record, we will be able to trace the original file that record came from, as well as some additional timestamps that we add here. We then turn that into a CSV file, which is this component right here. And finally, we land that CSV file in another location or another folder in our S3 bucket. So going back to the master job here, once that child job was executed, we have a few additional steps here. You can see them colored in green, which are just responsible for things like archiving the files that were loaded and doing some other organization things. So that concludes our first master job. The next master job that we're going to look at is responsible for executing the copy command, which takes the CSV file that we just created and ingests it into Snowflake. So this master job starts out very similarly to the previous one. We read the relevant variables from our control table in Snowflake. And we then iterate through a few steps here and eventually execute this child job again, which is called copy to ODS. Now, in this case, we are again executing another job, but it's not actually dynamic. This is because in this case, the child job is generic enough that it can actually execute the copy command for multiple different tables, and we don't need to create a specific job for every single table that we have. So we're going to look at this job now together. And what we're doing here is we're basically constructing the copy command that we want to execute. So I'm just going to skip a few steps here for you to see exactly what the copy command statement that we're constructing looks like. So if you've ever seen a copy command before, this is what it looks like. It has this copy into, and then we define the target table that we're loading data into. We list all of the column names in the target table that we are populating. And after this from part, this is the location of the files in S3 that we're using to copy the data into. And then we just have some additional settings and parameters that we can define. So you can see that most of the statement here is generic, and we're going to populate it during runtime to make this copy command fit for multiple different tables. The way that we're doing that is, again, partially from feeding parameters from that control table that I keep mentioning, but also specifically for the column names that we need to populate, we're pulling that with this step right here, where we're querying the information schema in Snowflake to get the exact column names that we have in our target table. We're ordering them according to position, concatenating them, and then inserting them into our expression. We then execute our copy command in Snowflake and finish with some logging steps. So we do want to show you what that copy command looks like. So for that, we're actually going to go into Snowflake and just going to define here the context. So we're going to use a large virtual warehouse to run this execution. And just going to truncate the table and run this command. So this copy command right here, starting in row 22 that you can see here, this is very similar to the copy command statement that would have been generated by Talend. We just wanted it to be a bit more visual for you to see the results here. So we're copying the data into this target table called store sales. This is the location of the files that we're pulling from. And here are some additional settings, like the type of the file is S3 because this is after we've already parsed the data. So this does take a moment to run. So I'm going to go back into Talend and go through another thing, and then we'll go back to see the results together. So once we've completed this copy execution, going back to the master job here, that kind of concludes the master job as well. The rest of the steps here are again related to logging. And what you see here on the bottom is actually a data quality check, which we'll get to in the next part of the demo. So the next thing that we wanted to show for scalability is the ELT components in Snowflake. In Talend, sorry. So for that, we have this separate job in Talend, which utilizes those ELT components. So in the palette here on the right side, you can see there's an ELT section here, and there's all kinds of built-in components here. And the cool thing here is, this looks like any other ETL job or pipeline that you've probably seen before. But the unique thing here is that when this is executed, it's going to run on top of Snowflake using Snowflake's compute power, which is very strong, very elastic. We can leverage the functionality there, and we don't have to process that through Talend. When we're talking about huge data sets, that becomes really significant. So the job here is very simple. We're just pulling data from two tables, and we have this step to do a join between them and just to define exactly which columns we're taking from each of these source systems. So we won't execute this right now, but just to give you guys an idea, this processes about 1 billion rows from the sales table, and this takes like 5 or 6 seconds to run. So going back to Snowflake here, the copy command will probably finish in a couple of seconds, and then we will be able to look at the results together. There we go. So the copy command finished. It took a little less than 3 minutes. If I'm just going to do a quick select count from the table that we just loaded, you can see that we had a little less than 1 billion records ingested into this table. It was empty before I truncated it, before we ingested data into it. So 1 billion records for less than 3 minutes, that's pretty impressive. And that was with a large data warehouse. We can, play with the virtual warehouse settings here if we have even a larger data set or we want to achieve even faster performance for this. So going back to our presentation here. So that concludes the first part of the demo for scalability, and we will now move on to reliable. So why is reliable important? In order to have a successful adoption of the solution, the users have to trust the data, and very often we see issues with that, whether that's because of data quality issues or lack of monitoring causing issues to be identified by end users rather than data engineers. It's important to understand that this trust is a critical component of the success of the solution. So here are two examples of how our framework addresses this objective. So first, we put a lot of emphasis on logging every step of the data flow. This allows us to monitor every single step and very easily detect if there was an issue and where exactly it occurred. We can set up different alerts with detailed information about the specific failure, and it also allows us to analyze things like performance over time. The second example here is implementing data quality checks and actions as part of the ETL flow. As we established, in order for our users to trust the data, we have to detect and mitigate data quality issues. We do that by checking for issues like duplicate keys, missing information, thresholds, and things like that, and then applying different actions accordingly. For example, do you want to include flag data into the data warehouse or keep it separate for someone to look into? Do you want to roll back the data to reflect yesterday's data? Automating these steps ensure that we constantly monitor and control the data quality health of our system. So we will now go back to the demo and show an example of how we do the logging and how we implement data quality checks. So going back to Talend here. So I'm going to go back to the same job that we were looking at earlier, which did the copy command into Snowflake. And as you probably already saw before, every kind of major step here, we have a few things. We have a log start and a log done, and we have that a few times throughout the job. And that is true for any job that we have as part of a solution. If we look at the repository here for a second, you see under our admin folder, this is where we have all of our generic job logs, and we will look at just one of them. So this is our start log, and the job itself is very simple. It basically adds a row into the logging table that we have in Snowflake, and anytime for multiple steps throughout each job, we insert a row here with the specific job name that we're executing, the timestamp, status. If there was a failure, we will capture their error message and the time that there was a failure and things like that. If I go to Snowflake just for a second and query that logging table, you can see the results here. We end up with all the different jobs that we execute, the time that they took. If there was an error, we would see the error message here, and exactly how long each step or each job took to run. The next thing that we wanted to show here was the data quality check. So again, I'm continuing with the same master job that we've been looking at. And the last step right here is a data duplication check. So once we've loaded the data into ODS, we might want to check if there are duplicate keys in the data set and decide what we want to do with them accordingly. So we do that by executing this generic job again, which we will look at. So if you look at the palette here, there is a data quality section, which has a lot of built-in components that allow to very easily detect different things or different issues with data quality. Specifically for this example, we're using this T-unique row, which allows us to very easily detect, define the primary key of the data set that we're working with and detect if there are duplicates or not. What's happening specifically here is that if there are duplicates, we're doing two things. The first thing is that we're logging the total number of duplicates that were defined, and we're adding them to a specific log table that we capture for data quality issues. The second thing that we do is that we also send an email to the person responsible for this specific data set with the exact records, with the specific examples of duplicate keys that were identified. And that, as you can see, happens during the execution of the ETL flow. So as soon as these records are loaded, this person will be notified and we can decide what is the action accordingly. As I mentioned, there are other actions that we can define and set up automatically to happen throughout the ETL process. So going back to the presentation now. So that was our reliable section. And now we will move on to the last objective, which is accessible. So this one is pretty self-explanatory. We're building a data warehouse for it to be useful for our users across the organization. None of the effort of building the data warehouse is worthwhile if the data is not consumed and utilized to make business decisions. However, even though the concept is clear, there are still some common issues here. We commonly see a mismatch between the data sets created and the exact business questions that different types of users in the organization have. For example, executives might require dashboards with organized, clear information to consume. But if you have data scientists in the company, they usually want access to raw data with minimal transformations. Another example is creating data sets that are too specific, making them too inflexible to address other use cases or new business questions that come up during analysis. There is actually a lot that goes into the accessibility of the data warehouse. We'll share just two things from our framework. First, IT must keep the business requirements in mind when designing the data model of the data warehouse. The data warehouse model should not be just a data dump of reflection of the source data. In order to achieve meaningful insights, the data has to be structured, like when combining different data to enable cross-system analysis. Secondly, IT must strive to create ready-to-be-consumed data sets. The data model must be structured in a way to serve multiple use cases and user types. Executives want summaries, analysts want detail. In the data model, there is no reason to separate those. There's no reason to duplicate the same data many times at different level of granularities. The data model should work to support different use cases and then tailor specific data sets for those specific use cases in the reporting layer. At that point, minimal transformations will be required. That ensures that the entire organization is looking at the same numbers, no discrepancies or other different versions of the truth. It also decreases maintenance efforts whenever there is a change required to data model or logic. Back to the demos, this time in Snowflake. So the first thing that we'll show is how Snowflake rules exposes different data sets to different types of users depending on what they need. And secondly, how we can easily create data sets for exploration using a function in Snowflake called zero copy clone. And we'll finish with what I think is one of the coolest features of Snowflake, and that's time travel. So the first thing that we can see here in terms of role is that I've been using throughout the demo this role for a developer, which means that if we look at the database that we've been working with throughout the demo, I can see all the entire database. I can see the admin schema, which has all of the log and control tables that we've been talking about, as well as the ODS layer and all the other schemas in the database. Now, if I were to switch, and let's assume for a second that I'm an analyst, and I refresh the repository here, you can see I now can see within the same database, I can only see two schemas. I can see the data warehouse schemas, which has the data sets that are ready to be consumed, and our reporting layer. So that's a very simple example, but we find this functionality very useful to very easily restrict different access and while still allowing certain roles and certain people in their organization to have access to the database and explore the data. The next thing that we're going to talk about is zero copy clone. So I'm just going to run this statement and explain what this is exactly. So zero copy clone is a very cool feature which allows us to create a copy of the database. So what we're doing right now is we're creating a copy of this Talend Snowflake webinar database that we've been working with throughout this entire demo. And we're creating another database called Finance Sandbox. So you can see that execution finished. It only took 15 seconds. The reason this is really cool is because this allows to create a sandbox for, let's say, someone from the data science team who wants access to the different layers of the database, but we don't actually want to expose the production database to them and have them mess up with our data warehouse that is consumed by other users as well. The reason this was so fast is because it didn't actually replicate the database. So if you remember, the way that Snowflake is architected is that it separates compute from storage. And in this case, it didn't actually replicate any storage. It just created another layer of metadata. So now our data science team have this sandbox database, which they can use, and it won't interfere with our production environment. So this is the database that was just created, and you can see it has the exact same schema and structure and table and data as the original database. Now with this data, we'll now go over a few cool features that can be done. So the first thing that we're going to show are these time travel functions, which I mentioned. So in short, this is exactly what it sounds like. It allows us to go back in time and look at different tables the way they were a few minutes ago or a few days ago. This allows to go back in time up to 90 days, which is very powerful. So we're just gonna go through a simple example here. Let's say we're querying from the customer table. And for some reason, we do not think that the name of the customer here is correct. We want to change it so that someone can look into this. Now we execute this update statement that you can see here. I'm on row 61. But accidentally, I didn't just update the one record that I meant to. I actually updated the entire customer table. So if I now do a select from the table, you can see that all of the tables have this new name. This is not right. So this is not what I meant to do. Luckily with Snowflake, that's really not a big deal. So the first thing that I can do is I can use this offset function. You can see here, row 69, to look at the table as it was 90 seconds ago, and then I can see the original name that I had. And I can also restore the table to be as it was exactly 90 seconds ago. And now if I run that same name query, you can see I have all of the names back in place. So again, that's just a very simple example of how to use time travel. We find this functionality very useful, both for analysts, data scientists who want to explore the data, but as well as for us, frankly, during development. Sometimes things happen, and this is a very beneficial function that we often use. So to recap what we covered today, we talked about what makes a data warehouse implementation successful and different principles that go into different design elements of the solution. We find that using modern cloud technologies, Talend and Snowflake are the best fit to warehouse large data sets. Talend gives us the flexibility to implement every aspect of our best practice framework, while Snowflake just makes everything easier, offering a combination of scalability and elasticity for quick performance on large data sets. That wraps up our presentation for today. Thank you for joining us. We will now move on to questions. You're welcome to send them to the host or presenter in the chat.